All right, so we're going to take a look at the 1.2 homework, 1 to 10 all, skip number 6, some practice with the chain rule. Now remember, some people like to do their derivative of the inner function first, some people like to do their derivative of the outer function first. It's really just a matter of preference. A good rule of thumb is to recognize that you aren't done with the problem until you've taken the derivative of everything. All right, so first things first. In this first one, I've got x cubed plus 4x minus pi inside the function to the negative 7th power. So I need to take, and I just noticed I made a careless mistake, so I need to take the derivative of something to the negative 7th power, and so that's going to get me negative 7 something to the negative 8th power. Well, that something to the negative 8th power is the original function x cubed plus 4x minus pi. Now that I've taken the derivative of something to the negative 7th power, I just need to take the derivative of what was inside. And so my derivative of x cubed is 3x squared, my derivative of 4x is 4, and then of course pi is just a number, so its derivative is 0. From there, people typically rewrite with the shorter polynomial first, but there's no reason that you couldn't have given this as your answer. All right, number 2, took the time to rewrite my fourth root as 1/4 exponent. So I need to take the derivative of something to the 1/4 power, and that's going to get me something 1/4 times something to the negative 3/4 power. And then of course that something was the function that was already inside there. And my derivative for 1 plus 2x plus x cubed gets me 2 plus 3x squared. And again, I'll rewrite. Mathematically, we don't have to, but typically people put the shorter polynomial first. Number 3, conveniently, I'm able to rewrite this fifth root of something to the 3rd power as the 3/5 exponent. And so that leaves me needing to take the derivative of something to the 3/5 power, which is 3/5 times something to the negative 2/5 power. Well, that something just happens to be the original inner function. From there, I take the derivative of the original inner function, derivative of x to the negative 1st, derivative of 2x, and then the derivative of e to the x is e to the x all over again. And then again, I rewrite. Mathematically, you don't have to. Number 4, I've got something to the 37th power. So I know that something to the 37th power is 37 times that something to the 36th power. And then I need the derivative of that inner function. So the derivative of x cubed, the derivative of 2x. And then, like the others, I rewrote. Number 5 really kind of focuses on notation more than a specific function. So they give me some specific values. They tell me what f of x equals. So I know the derivative of e to a power is e to that exact same power all over again. And then I need to take the derivative of that power. So I end up with e to the g of x times g prime of x. From there, I can start substituting in. So I substitute in 2 for x. I know that g of 2 is 3, g prime of 2 is negative 4, and so I have my final answer. Number 7, I'm able to rewrite my square root. I take the derivative of my square root, so I have 1/2 times what was inside the square root to the negative 1/2, and then I take the derivative of what was inside. The derivative of 3x squared minus 4x plus 9, 6x minus 4. And as I've done in the past, I rewrite with the shorter polynomial first. Number 8, I convert my 7th root to being the 1/7 power. I know that I need the derivative of something to the 1/7 power. The derivative of something to the 1/7 power is 1/7 times that something to the negative 6/7 power. I have my original function from inside the 7th root there, and then I take the derivative of x cubed minus 2x and get 3x squared minus 2. And again, as you've seen, I rewrote, but you don't have to. Number 9 is a double chain rule. Since I've got e with an exponent, but then that exponent has a function inside a radical. So I rewrite. Now, this is a good example where you know that you're done when you've taken the derivative of everything. So the derivative of e to a power is e to that exact same power all over again. And so I know I've taken the derivative of e. What functions are left? 9 minus x squared to the 1/2 power. So I take the derivative of something to the 1/2 power, and now that part is done. If I'm looking at the original problem, the only thing I don't have the derivative of is my 9 minus x squared, and the derivative of 9 minus x squared, negative 2x. I've got a little bit of simplifying because the 1/2 and the -2 are going to result in -1. We typically move single variables to the front. Whether you have these two interchanged is up to you. And so finally, number 10, I've got e to the square root of x, or in other words, e to the x to the 1/2. So I take my derivative of e to a power, which is e to that power all over again. I take the derivative of something to the 1/2 power, and then I rewrite with my variable in front. All right, hopefully this helps. We're going to spend another day on the chain rule. Again, if you have any questions at the end of the video, please feel free to ask when we return to class next week. Have a good one.